Hello, my name is Davis Binger, and let's talk about work and Hooke's law. Today we will be performing problem 6 of the 6.7 handout, in which we will calculate the work required to stretch a spring 0.5 meters from equilibrium under the assumption that it requires a force of 50 newtons to hold the spring stretched 0.2 meters from equilibrium. Before solving this problem, let's consider a general conceptual outline for spring problems. Typically, we will be asked to find the work required to stretch a spring over a given interval. And to solve this problem, they will provide a bit of information. Now, this bit of information comes in one of two forms. Typically, it will be either the force required to hold the spring at a specific stretched position, as in the problem at hand, or it will be the work required to stretch a spring over a separate interval. Now we have these three quantities: the force to hold, the spring constant, and the work to stretch. And these three things can all be found from each other. So if we're looking at the force to hold, as we have in this case, we will use that information to calculate the spring constant for the spring at hand, and then we will use that spring constant to calculate the work. In the other case, where we're given the work required to stretch a spring over a second interval, we will start over here, and using this bit of information, we will then go back to calculate the spring constant. And with this spring constant, we can calculate the work over the interval we're actually interested in. The first two relate directly by Hooke's law. Recall that the force required to hold a spring in a specific position is related to displacement by the formula F equals K times X, where K is the spring constant. Now recall that work is related to the spring constant by the relation that work is equal to the integral from A to B, where A is the interval where we're stretching from A to B of K times X dx. So if we have any of these, we can move in between them and find the work, the force to hold, any quantity we're interested in. So let's take this information we have, that it requires a force of 50 newtons, that's this F here, and we are displaced 0.2 meters, that's this X here, and we will calculate the spring constant. So by Hooke's law, our 50 newtons is equal to K times 0.2 meters. From this we can calculate that our K is equal to 250 newtons per meter. And we can calculate the work. We are interested in the work done moving the spring from a equilibrium position, which is 0, to a displacement of 0.5. So we will be integrating Kx, in this case K is 250, from the interval 0 to 0.5. 250x is a simple function to find the antiderivative of. It's just 250 times x squared over 2. And we evaluate this from 0 to 0.5, which is just 250 times 0.5 squared over 2, which simplifies to 125 over 4 joules. Thank you for watching, and as always, if you have a question, feel free to leave a comment below or email me at binger@math.ohio-state.edu. Have a good evening.